Good evening, friends. Good evening, all of you. So Shubham is asking a question. No, Shubham, that is just your imagination. The virtual reality is only your imagination. Your virtual self cannot bleed. Your virtual self cannot get pain or hunger. And if he is put in that situation, you will also don't bleed. You also will not feel any pain and all. Just like, for example, if you watch a 3D movie, okay, a 3D action movie, you will feel as if a bullet is coming towards you. But will it hit you and kill you? No. So just like 3D, it is a more immersive version of 3D. That's it. That is just your imagination. Is it clear? Compare it with 3D movie. In 3D movies, for example, 3D Jurassic Park, if you go, you feel as if the dinosaur is coming onto you, but that dinosaur cannot harm you. Okay, that is just our imagination created by our mind. Okay, now how office work complete? You will do it now. Okay, you will only do it. For example, have you ever played any games like this PUBG and all? Okay, so you will play. You will control the remote. Your virtual avatar will be there. Is it clear? Okay, you are controlling your virtual avatar, right? And you will get that feeling as if you are really playing it. Okay. Fine. In the last class, we started Internet of Things. जब things में internet है वो Internet of Things है. Okay. Like this, I told you like variables. In what all things you can have internet? Variables, homes, cars, cities, etc. In cities, bills, or that is meters, smart meters for water, gas, electricity, etc. Is it clear till this point? Can you proceed? Yes. Then. So these are the general things like variables like smart glasses, fitness bands, etc. Homes like smart homes, cars, driverless cars, and cars that can communicate to avoid accidents. And cities like, say, for example, smart meters in the homes and all that. Okay, so this is general examples. So now let us proceed to, and yesterday one student was asking whether this IoT is related to artificial intelligence. Maybe, may not be. For example, the driverless car by Tesla is IoT plus AI. By Tesla is IoT plus AI, because that is taking the decisions of in which route it should go and all. It is not taking commands from the people. Okay, whereas like the other example, smart meters and all, they are just only IoT, not AI. So AI can be used in the IoT, but may not be used also. Okay. Then now let us see some specific examples where IoT is used in India. Okay, some specific examples in India. Between the capital city of New Delhi and Varanasi in Uttar Pradesh, the Vande Bharat Express, India's first semi-high-speed train, uses a collision avoidance system. I told you the cars that can communicate and avoid accidents. Same concept is kept in the Vande Bharat Express. And what is that thing in which internet is there? The Vande Bharat Express itself. The thing here is the train. Got it? The train is connected to the internet, so it can avoid the collision with some other trains. Okay, so comprising sensors and other IoT devices to prevent accident due to the human error or equipment failure. Next, one more example. In Kohima, data collected from sensors and other IoT devices is being used to manage street lighting. Okay, street lighting, like let me explain this. Sensors and IoT devices. Okay, data collected from them using such data, it is managing the street lighting. It means what? From this data, okay, it will get information about at what time the street lights should be on, at what time the street lights can be off, okay, in what places it is needed. So for example, the number of vehicles traveling in one particular road, there is a heavy traffic there, so you need proper street lighting there. Okay, in some other place the traffic is less, so you can minimize the street lighting there. Okay, so you are using the data collected from some sensors and IoT devices to manage the street lighting, ensure public safety, okay, and deliver a slew of citizen services. Is it clear? Means, for example, it will collect data about in so and so road there are more thefts happening. Okay, so provide a CCTV camera there or more street lighting there. Okay, so this is a safe area, nothing is happening, all good. Then you need not probably have so much care on this particular area. Okay, so the data about the crimes, the data about the theft, or all this information is used to manage the street lighting and other safety issues. Okay, where it is used, in Kohima it is used, and these are the specific examples we are discussing. Can we proceed? In agriculture, Tea Trantum, okay, a supplier of wellness and premium teas, a company called Tea Trantum, okay, in India, is using IoT technology to monitor moisture content and maintain the ingredient proportions of some of its products. Okay, clear? So it is using Internet of Things to monitor the moisture content in the tea leaves in the soil where the tea plantation is being cultivated. Okay. Plus, it will also use data collected from the IoT devices to maintain the ingredient proportions. Okay. Then the Indian IoT market is expected to reach so and so billion by 2025. Okay. And so these are some static information that you have to remember. Okay. Then other applications of IoT devices. Transport and logistics, I told you, driverless vehicles. Okay. Collision avoidance systems in the vehicles like Vande Bharat and other cars and all. Okay. Utilities like smart meters, smart grid management, electricity grids managed. Okay. So the electricity grids are interconnected to the internet. Okay. Then smart cities, smart buildings with smoke detectors, home automation, etc. In agriculture, climate, agriculture monitoring, livestock tracking. Okay. Then environment, flood monitoring, alerts, etc. Industries, process monitoring, control, maintenance of the stocks and all. In consumers, wearables. Okay. Senior kids and senior citizen trackers. Is it clear? For example, a smartwatch is given to the kids or senior citizens. You can easily track them where they are, because like they may not be able to communicate properly and tell the address to reach home safe. Okay. So therefore, they might be vulnerable to certain crimes and all. So you can track their position using this. So these are the other applications. Grid part. Electricity grids. Okay, we have transformers, electricity grids and all. Okay, so they are also equipped with the internet. It means you can monitor them using the internet. You can control them using the internet. So the thing here is like an electricity transformer or a grid. Is it clear? The thing which is having the internet is an electricity grid. Moisture content can be monitored. They keep a device like smartphone-like device that can sense the moisture content and communicate with you. They keep some devices installed in the crop, okay, in some places, so they can gather the information and they can communicate the information to you. Is it clear? Okay. So first, okay, like this one, agriculture moisture content here. What is moisture content? Let me try to little clearly explain it. In moisture content, moisture sensor, something that can sense the moisture, is the thing. So this thing is connected to the internet. Why it should be connected to the internet? Moisture को sense करने के लिए नहीं, जो इसने sense कर दिया वो information को आपसे communicate करने के लिए, to communicate data to the people controlling it. Okay, it means I can sit in my home, okay, and I can get the data from the sensors in the crop. I need not go to the crop. Sensors installed in the crop. I'll sit in my home. The sensor will send me the information about the moisture content in the soil. The sensor can use radars, okay, the different systems, okay. Moisture. If you ask me the sensor is made up of what, the sensor can be made up of a radar also, okay, or else some other sensor, any type of a sensor. It is connected to the internet to communicate the data to the people controlling it, okay. So then, and you may also ask me, how can you say ingredient proportions? Ingredient proportions. Did you hear, like, did you observe it sometimes, like in the artificial intelligence and all? If you purchase something, then it will keep suggestions about the similar things. Okay, so like the people who purchased that also purchased this. That is something that we experienced. Okay, and if you watch some web series or some type of videos, the YouTube and all will go on suggesting you similar types of videos. Okay, till that much we know. Also, did you notice that sometimes you did not search anything? घर में bedroom में बैठ के family member से property purchase के बारे में discuss करे तो next day you will get messages about like some real estate companies and all. They start sending you the messages. You did not search anything. You're just talking with your family members. Did you notice it happen sometime? Yes. Okay. Observe it. Observe it. If we are discussing about something, the business from that okay will okay kind of they send we get messages, more messages about that. Okay. Then observe that sometime if you did not observe as of now. Then how that happens? Because we have mic in our cell phone and all, isn't it? We have mics in our cell phones, so they're collecting the data from us. Then you may think that, say for example, okay, I'm taking a cup of tea. While taking a cup of tea, I will say it is very light. It is not having proper flavor in this. So the tea Trantum will come to know about that. Did you understand? The tea Trantum company will collect all such data, so it will make the tea more flavorful. Okay, then I thought इसमें थोड़ा इलायची भी है तो अच्छा लगेगा. Then they will make an ilachi flavor tea. Did you understand? So moisture sensors, like ingredient proportions, etc. Is it clear? Doubt in any other example? Doubt in any other example? You think you will understand, like even like I'm not saying because I studied somewhere, okay, so like I'm just thinking on this and telling you, so you can also think if you get one or two doubts. Then after that, IoT issues, security challenges, like some student was commenting there is no privacy. Yes, privacy breach, okay, privacy challenges. Then connectivity challenges, for example, driverless car and buffering, right or left, no decision, accident. Okay, collision avoidance system, because collision avoidance system is there in Vande Bharat. If the driver takes less care of it, then what if the internet does not work? Then it can meet with the collision. Okay, compatibility challenges. It means, for example, compatibility challenge means, okay, I told you IoT, if I have IoT technology, I can switch on my air conditioner 10-15 minutes before I reach the home. But for that, first of all, I have to throw my AC and purchase a new AC because my present AC is not compatible with IoT technology. Did you understand? So compatibility challenges. घर में जो भी appliances है, वो सारे appliances को फेंक देना और नया खरीद लेना. So compatibility issues. Is it clear? So key IoT initiatives in India. Will you go through this? There is nothing technical to explain some initiatives by the government. Will you go through this? Next. Okay, edge computing. Okay, we understood what is edge. We understood what is IoT, but there is a more latest technology that is edge computing. So what is the difference between IoT and edge computing? Okay, so to understand that, I have given a small story here. I will not explain you that story, but I will just tell you that story. Okay, for example, if you are using IoT, okay, IoT in a bus, let us suppose in a bus or in a metro train, and that is the thing. Okay, IoT means what? Internet of thing. So यहाँ वो thing क्या है? Bus या metro train. Okay, can I proceed? Okay, and you got into the bus. Okay, and like you swipe the card, like metro card will be there, na? So like that you swipe the card. Is it clear? Okay, then once you swipe the card, so you entered into the metro. Okay, and then swipe the card. Then after that, what it will do? Okay, the metro train sends information to a distant server or a distant processor. Is it clear? Entered into the metro, you swipe the card. Okay, the thing is the metro train. The metro train has sent this card में जो भी information है, so that card information goes to a distant processor, okay, or a distant server. Okay, and then like that will send the information, okay, back to the metro. Is it clear? Okay, about the balance in the card, okay, or cutting the money and all. Is it clear? Okay, so the distant processor will check the balance. Balance check करके अगर card में balance है तो it will cut the required amount of the fund from your card. Is it clear? And it will send the information, okay, back to the metro. Here the metro is the thing we are discussing about. Okay, is it clear? Understood? So you swipe the card in the metro, that is the thing. Then the thing sent the information to the processor. Then the processor processed the information, balance check करके correct amount cut कर दिया, and then it will send that particular information back to the metro train, and then like the metro train will permit you to enter. Is it clear? Okay, or permit you to stay if you are already in the metro or you are already in the bus. So then it is called as IoT. Is it clear? In that case, this technology is called IoT. Then okay, what in edge computing what happens? In edge computing what happened? You entered into the metro and you swipe the card. Okay, and okay, balance checking and cutting the amount. This kind of processing happens in the metro itself. It means in the thing itself. If the thing itself is processing it is not sending the information to some distant processor. Did you understand? Processor भी thing में है. Then we call this as edge computing. I hope the difference is very clear. The difference between IoT and edge computing. Okay, so why this is called edge computing? Okay, because the processing occurs at the edge of the user. Okay, processing occurs at the edge. This is the difference between, for example, like if my AC is connected to the internet, but I'm processing it with an internet with a then it is IoT. Is it clear? If the processing also happens in that air conditioner, then it is edge computing. Is it clear? That is, the air conditioner is having a small processor, like a CPU like thing is there in the AC. Then it is called edge computing. Agar processing unit edge par hai to, okay, thing mein hi processor bhi hai to, that is edge computing. I tried to explain in 2-3 different ways because if at all there are 1 or 2 people who did not understand it. Okay, so the same story, like this story which I have written here, it is there in this. You can go through that. Okay, so now look at here. These are the edge nodes, edge devices. Sorry, edge devices means like car, driverless car, collision avoidance system car. Okay, homes, smart homes, your mobile phone, air conditioner. I've been saying AC because okay. So your vacuum cleaner, robotic vacuum cleaner. Okay, your oven, microwave ovens and all. Okay, these are all the edge devices. And see, look at here. These are edge nodes. It means all of them do not have a common node. Okay, they have different nodes. Is it clear? So iska ek alag node hai, iska ek alag node hai, iska ek alag node hai, aur iska ek alag node hai. Okay, node bole if you remember in supercomputers, node is nothing but processor. Okay, when there are many processors, one processor is called as a node, isn't it? Clear till this point? Okay. Okay, all clear. Computing closer. Computing bole to kya hai yahan? Processing. Closer to the source of the data. Is it clear? So what is the source of the data? For example, where did you swipe the card? In the bus. So the bus only should process it. Is it clear? Because if, like, what is the problem in IoT? Okay, I told you the difference in IoT. What is the problem? If there is some buffering here, okay, it means by the time the metro sends the information to the distant processor, internet connectivity mein kuch problem hai. But it's okay, we'll wait for 5 more minutes. Nothing happens. It's not some life risky thing. But what if a driverless car keeps communicating with a distant processor? Okay, so right or left? Wait karo, main pooch ke bataungi. Is it okay? Yes. So it cannot ask and tell. Internet is in IoT also. Internet is there. Processing unit is also there here. Internet nahi hai to how can it even send the information to a distant processor? Is it clear? Okay, to send the information to a distant processor also you need internet. Not only सिर्फ internet है तो IoT, internet के साथ साथ अगर processor भी है तो edge computing. Is it clear? Then, so bringing the computation and data storage closer to the source of the data. Not only processing, storage also happens. It means the metro card data will be stored in the metro itself, not in some distant server. Is it clear? Data storage and processing happens at the edge. It minimizes the need for long distance communication. Time. It improves response time and saves bandwidth. Is it clear? You don't need high speed internet for edge computing. But IoT ke liye, like you need a very high speed internet. Okay, so because you don't need a very high speed internet, it will also save the bandwidth. Edge computing is about processing data locally. Okay, process the data where the data is generated. And cloud computing is about, okay, IoT is related to cloud computing. Do you agree? IoT is about cloud computing. So in cloud computing or IoT, it is about processing the data in the data center or public cloud. So in IoT, which uses cloud technology, the data is stored and processed in a distant server called cloud. In edge computing, data is processed by the device itself, okay, and or by a local computer or server, rather than being transmitted to the data center. Due to the increased use of technologies like IoT, AR, VR, robotics, machine learning that require service provision closer to the users, edge computing helps solve the key challenges of bandwidth, latency, resiliency. Agreed? In lesser bandwidth, you can solve the problem of latency. Come speed ka internet net ko use karke bhi latency ko avoid kar sakte because it need not send the information and get the command back. So that's it. That is edge computing. Okay. Then so IoT over, edge computing over. Next concept. Okay. So cloud and IoT more related or cloud and edge more related? Cloud technology is to IoT or edge? Little disappointing, but it's okay. No problem. I will explain one more thing. Okay. Cloud is more related to IoT. Okay. Not edge. Because what do you mean by the cloud? The cloud means a distant server or the data center. For example, in your laptop, if you are using, okay, wait, Abhishek, in your laptop, if you are using MS Office, वो MS Office के बारे में data कहाँ पर है? Okay, some data center में है. Is it clear? In the cloud, cloud is nothing but a distant server, okay, or a data center, okay, or a distant processing and computing. Okay, do one thing, just think about it. Cloud, okay, is cloud in your hands? Can you touch and feel cloud? Or cloud is somewhere distant, beyond the reach. Okay, पता भी नहीं है कौन सा altitude पर है. So same way, cloud is related to the distant server. Just like the cloud is somewhere at a very high distance, same way in cloud computers also, the data center is somewhere out of reach. Okay, I repeat, normally just like the clouds are out of reach for us, very distant from us, same way in cloud computing also, the computing, the data center or the server, okay, the place where the data is stored and processed is somewhere out of reach, very distant. Then it is called cloud. Both Anuj, okay, self-driving cars, driverless car can be an IoT or edge. But if it is edge, it is better. Okay, driverless car will be more safe if it uses edge computing instead of cloud computing. I repeat, driverless cars can use either IoT or edge, no problem. Okay, both are being used. But if they use IoT, is key because they have to, okay, like in a driverless car, if you use IoT, then the driverless car will say, okay, you are at the center, at the chowras, at the junction, and you have to decide right or left, and your driverless car will say, madam, rok lijiye, main pooch ke bataungi. Is it clear? So that is the problem if IoT is used in the driverless cars. But if the driverless car is equipped with edge, then it will fatafat se decision lena possible. It will decide whether it is right or left. It need not communicate with something. Is it clear? Anything you can use, but edge is safer. Okay. In the metro bus also you can use anything. Like say for example, a metro bus with IoT possible, a metro bus with edge possible. Okay. So, but in the bus or metro, if you are using edge, then it can quickly give you the ticket. Okay. It can quickly permit you. Okay. Checking the balance in your card and cutting the required amount of the amount, it can quickly permit you into the bus. Okay. Agar wo bus IoT se equip hue hai to, then you have to wait for 5 minutes. Okay. Like it is asking the distance server. Is it clear? You'll have to wait there. Is it clear? So I hope it is clear. Just remember the clouds are very, such may clouds, I'm speaking about the rain causing clouds. So they are somewhere distant. So same way, if the data is stored and processed somewhere distant, then it is called cloud computing. That is IoT. Okay, if the data is stored and processed in the thing in which it is being used. Okay, so then it is called edge computing. Anything we can use, but if you edge is more efficient when compared to IoT. Clear till now? Yes. So is cloud technology more related to IoT or edge? Is cloud technology more related to IoT or edge? Very good. Maybe you are also IoT, so like you asked the distant server and then you are answering now. Okay, okay, no problem. Jaldi say edge computers bano. Okay, now the next concept we are discussing is big data. Is it clear? Okay, so this is totally next concept, like not a continuity of that IoT or edge. So switch your mind. Big data means what? Okay, the data that is big. Okay, means what? Enormous amount of data being generated is called big data. Enormous amount of data being generated is called as big data. Is it clear? So it refers to the data that is large, plus contains diverse sets of information. The sets of information means what? Maybe like a word, okay, like a PDF, like an audio recording, like a video, okay, or like a PPT. Okay, in different formats we have, isn't it? In the internet, we are getting data in diverse sets. Okay, different formats we have. And also that grows at an ever increasing rate. Day by day, the amount of data is increasing. Okay, so that is called big data. For example, we have big data in the YouTube, yes. Okay, because yes, it is large amount of data and it contains diverse sets of information, different types of information available in that, and it is growing at an ever increasing rate. Day by day, the YouTubers are increasing. More and more videos are coming in the YouTube. So like same way, like say for example, Twitter, Facebook, Instagram, all these also are having big data, isn't it? Yes, all social media. Okay, because more and more people, the users of Meta, that is Facebook, increasing, the users of Instagram increasing, the users of Twitter, we have to see because some changes happened. Whether they increase or decrease, we have to see. So on the whole, the users of like this social media are increasing. So more and more data is being generated. That is called big data. Okay. The different types of data originate from sensors, devices, video, audio, networks, apps, that is applications, okay, social media, etc. in the real time at a very large scale. Okay, and features of the big data. Can we proceed? The characteristics or the features of the big data. Okay, and first one, volume. Volume means lot of data is there. Next one, velocity means speed. It is accumulating at a much higher speed. Varieties are the different formats of information is available. Okay, value. The data has an intrinsic value in itself. Is it clear? The data is very valuable. For example, if I keep my notes in some OneDrive, then it is very valuable for me. It's make intrinsic value. Okay, so not probably a monetary value. It means you cannot exchange, like how costly is my, like I mean not a copy of it. अगर वो डाटा को पूरा तरह लेना बोले तो how costly it will be, I cannot say, isn't it? You can, it's not a conversion value. इसका एक अलग value. It's not only money conversion value. Okay, intrinsic value is there. Is it clear? Veracity, it is about accuracy. Okay, accuracy of the data. Okay, these are the characteristic features of the big data. Same characteristic features in the image format. Okay, volume, huge amount, variety, different formats, value. Okay, extra, like intrinsic value is there, velocity, at high speed it is accumulating, veracity, accuracy. So these are the characteristics of big data. Uses of big data. Okay, what are the uses of it? First one, product development, for example. Okay, by gathering more information about what kind of videos the people are watching more, Netflix can produce, okay, more that kind of series. Do you agree? For example, if more people watch some Mr. Strange or something, more similar web series, similar videos will come, similar programs will come. Okay, so same way, like Amazon and all, they use for the development of their product. Is it clear? Then customer experience. Big data can be used to improve the customer experience, isn't it? Okay, data can be gathered from social media, web visits, and other sources to improve the interaction experience and maximize the value delivered. It means your social media platforms can be more interesting to you, more useful to you. Okay, the more and more data they have. Okay, because they can make changes to make it more. Then predictive maintenance. Okay, by analyzing the indications of potential issues like mechanical failures in vehicles before the problems happen, the organizations can deploy maintenance more cost effectively and maximize parts and equipment use time. Okay, it means like say for example you purchased a car. What the car company will do, it will have a big data about what kind of mechanical failures a car can have. Okay, so like it will keep giving you suggestions, like you have to give the car to the servicing. Okay, or like this problem is coming, it is better you solve it before so that you can save some money. So like that it can keep giving you the suggestions. Is it clear? It can predict the future problem so that you can solve it before it comes. Understood how it is possible? Based on the data of the previous such problems when the car experienced mechanical failures earlier. If your car is in a similar situation, it will warn you. Okay, fraud and complaints. Big data helps in identifying patterns in the data that indicate fraud. Okay, if you have more data, you can observe the patterns in the fraud and can avoid the fraud. What kind of data is being stolen? Okay, and the people who are trying to steal the data, do they have any pattern? It means like do they have any pattern in doing that? Is it clear? Do hackers have any pattern? What kind of accounts they are hacking? Is it clear? Say for example, viruses, like viruses means not coronavirus and all. Okay, computer viruses. Okay, that cyber crimes and all. Say for example, like some malware. Okay, some spyware. Okay, a pattern about the malware is sent to what kind of people? Okay, I'll give you an example. Okay, Pegasus was sent to the journalists and all. Okay, probably to keep a watch on them, like what are they doing any anti-governmental programs or something like that. So that is a pattern identified. Is it clear? How did we understand that the Pegasus is being sent only to the journalists? Okay, by observing a huge amount of data. Okay, to whom the Pegasus was sent. Okay, so these are the helps of the big data. Is it clear? Financial trading, obviously the more data you have about the share market and all, stock exchange and all, the more intelligent investments you can do, right? Dealing with pandemics, like predicting the peak, okay, when you are going to get the next wave, or when the next wave is going to peak, the next wave is going to peak at what numbers probably, okay? So such things is clear. And the study of the drugs efficiency, study of the vaccines efficiency, how many vaccinated people died, how many non-vaccinated people died, all such things. The more data you have, the more accurately you can predict, okay? So those are the advantages of like where we can use big data. Next one, issues, challenges with big data, the problems. A new set of complex technologies in the nascent stage of development and evolution. It means there are a lot of this edge computing. All these are in the nascent stages of evolution. Means early stages of evolution. We do not have much awareness about them. Okay, so unknowingly we can commit mistakes, isn't it? Okay, some of the commonly faced issues include inadequate knowledge about the technologies, data privacy, inadequate analytical capabilities of organization. Okay, like for example, it will, if you do not have adequate analytical capacities, big data is like searching a needle in a pile of grass. So retrieving that particular information which you want becomes difficult. So you need better analytical skills to use the big data. Is it clear? Okay. Huge amount of data creates problems such as storage and retrieval. When so much of data is being generated, where do we store it? And the more the data that is being accumulated, it will take more time to retrieve that piece of information which you want. Next. This is unstructured data. For example, if you go for Google search, you will get some images, some videos, some PDFs, some Word document type of things. So it means it is not classified into different formats. So this unstructured data with increase in the number of data formats complicate the information and amount of time needed to organize the data by data scientists. Data scientists को ज़्यादा time लगेगा to organize this data. Is it clear? Then it is like finding a needle, like I told you, like retrieving the data becomes difficult. Okay, this data is made available from numerous sources and therefore has potential security problems, privacy issues possible. Okay, so that's it. With this, we completed cloud, IoT, edge, and the associated applications and challenges. Can we move on to the next topic? The next topic that we are discussing is something that we left earlier, that is quantum computers. Okay, once again, totally different topic. You have to once again switch your mind. Okay. So what are these quantum computers? By the way, one small information. So I got cold yesterday and fever. How is it a big news that you are sharing? Nothing. But I have this larynx issue. I tend to lose my voice if I get throat infection. As long as I don't lose my voice, even if I'm not completely well, I'll take the class, because it's not going to some offline class and I have to take, instead of sleeping in my room, I'll sit here and take the class. So as long as, even if I get the other symptoms, I'll take. But if I lose the throat, you may get some gap in between. In that case, like if you are in a hurry, then you can watch the defense. Only 2 classes are pending after this class. You'll have only 2 classes pending, that is defense. By chance, if your subscription is ending, watch the defense 2 classes in the previous batch. Or else you will wait 1 or 2 days, I'll be back. But this only if I lose my throat. Is it clear? As long as I do not lose my throat, then I will definitely try to complete it off. Okay. So, like now coming to the quantum computers. Quantum computers, before we know what are quantum computers, first of all, what do you mean by the word quantum? Quantum means smallest possible discrete unit of any physical property. Okay. Means like, say, for example, photon is the smallest unit of light. Photon se chota kuch nahi hai light mein, isn't it? Smallest unit. Okay. An electron is a subatomic particle. Okay, so it means atom is not the smallest unit of matter. Why? Because within the atom you have electrons and protons. So electron is the smallest unit. But as such, with more and more physical knowledge increasing, they're trying to find, do we have any? It means like present physics, we have doubt that whether the subatomic particles are the smallest units, or maybe they are also further divisible. We don't know. Still, the studies are going on. So, like mostly based on our present knowledge, okay, the smallest unit of matter is called quantum. Is it clear? No, because okay, giant cell is like a huge. Okay, then is really the cell huge? No, you can have 1 million cells in one drop of water. You need a microscope to watch the cell. Okay, so how can you say it is huge? Because okay, in one cell you have, okay, wait, supramolecular assemblies are there, like DNA, protein, etc. In that you have molecules, in that you have atoms, in that you have electrons. So this is quantum. Okay, this is not quantum. So for quantum, the cell is huge. Okay, for the human sight, it is not huge. It is microscopic. You have 1 million cells in a small water drop. So I hope you understood what is quantum and how small it is. Okay, supramolecular means many molecules are there in that. Okay, molecule means what? CH2 is a molecule, because the carbon atom, 2 hydrogen atoms, that's a molecule. Okay, so like a protein is having many amino acids in that, it's a supramolecular assembly. Okay, so a cell will have lots of supramolecular assemblies. It may countless number of molecules, and molecules may countless number of atoms. And in the atom you have electrons. So electron is the quantum. Okay, so smallest unit of the matter. Okay, okay, quantum clear. Then what is quantum computer? Interesting. Quantum computers uses qubits instead of classical bits. Is it clear? Okay, so clear for all of you? Quantum computers uses qubits instead of classical bits. What are the classical bits? 0 and 1. 0, 1 ke jagah pe they use qubits. So what do you mean by qubit? Okay, there are several physical objects that can be used as a qubit. It means हम एक photon को एक qubit के जैसा use कर सकते, एक electron को एक qubit के जैसा use कर सकते. Is it clear? Qubits means quantum bits. Quantum bits means an electron or a proton, okay, or like a photon used as a bit. Okay, so then it is called quantum bit. Electron को एक bit के, normally bit means what? Bit or classical bit or normal regular computers में bit, okay, is 0 or 1. Okay, so एक electron को हम एक bit के जैसा use कर सके तो वो quantum computer है. Is it clear till now? Then you will get one doubt. How can we use electrons as a bit? Did you get this doubt? How can we use an electron as a bit? Let me explain. Okay, so do you agree that I'm now explaining what? How can an electron work as a bit? Electron को bit के जैसा कैसे use कर सकते? Right. Now, do you agree that electrons have a magnetic field? Every electron will behave like a tiny bar magnet. Not only an electron, a proton also. Every charged particle will behave like a tiny bar magnet. Is it clear? They are like tiny bar magnets. When we place them in a magnetic field, okay, what I'm explaining is like a needle in a compass. For example, रास्ता दिखाने के लिए आपके पास एक compass है. Is it clear? If you keep the compass like this, it means you are keeping the compass in the Earth's magnetic field. Is it clear? एक magnet को हम दूसरा बड़ा magnet में लगाए थे, right? We kept the compass in the Earth's magnetic field. Is it clear? Then what happens? Okay, the compass, okay, magnetic north, okay, coincides with Earth's magnetic north. Is it clear? If you keep a compass in the Earth's magnetic field, then the compass में जो magnet है, वो magnet का north pole, it will coincide with the magnetic pole of the Earth's magnetic field. Okay, and can I call this as, no? How can? Okay, so north coincides with north. Okay, then can I call it as north? Can I call it as low energy state? Okay, can I call it as low energy state? You are saying yes, but why? Okay, reason is why it is low energy state. You might have got the doubt, hesitated to ask. Okay, so why it is called low energy state is because जब वो नॉर्थ है, नॉर्थ दिखाने के लिए you need to drag the needle like this, जोर से वो needle को drag करना पड़ेगा या automatically it will align. So you don't have to put energy for that. Okay, जब वो सच में नॉर्थ है, नॉर्थ दिखाने के लिए, जब वो सच में नॉर्थ है, कंपास में नॉर्थ दिखाने के लिए needle को energy use करके drag करने का जरूरत नहीं है. Okay, so you are not spending energy there. Therefore, it is called low energy state. Okay, then now जब वो actually north है, okay, आपको south दिखाना है. Is it clear? It is actually north, but you have to bring the needle to the south. Then you have to forcefully drag the needle to the south. Do you agree? Needle को हाथ में पकड़ के ऐसा खींच के south तक लाना पड़ेगा. Is it clear? जब वो north है, आप south दिखाना चाहे तो you have to spend energy to drag it. Is it clear? Okay, so then it aligns. When the electron aligns, then it is called low energy state. When the electron is opposite, not align, opposite. जब वो north है, south दिखाने के लिए, high energy state. Do you agree? When I assume, okay, an electron as a qubit, okay, for the electron to align with the magnetic field in which it is kept, it is low energy state. For the electron to be exactly opposite to the Earth's magnetic field, then it is high energy state. Okay, so now what we can do is, we are assuming the high energy state as 1. Okay, we are equating the high energy state as the classical bit 1, and you are equating the low energy state as the classical bit 0. Is it clear? Assume the high energy state as classical bit 1 and assume the low energy state as classical bit 0. Okay, let me read it out. Okay, so electrons have, if something is not clear, it is like a revision. Complete concentration, please. Electrons have a magnetic field. They are like tiny bar magnets. When we place them in a magnetic field, they will align with the magnetic field, just like the needle of the compass aligns with the Earth's magnetic field. Okay, this is the lowest energy state. Okay, because it is lowest energy state, we also call it as spin down. Is it clear? Low energy state, we are also calling it as spin down. Here, down means not south direction. Down बोले तो energy कम है. Okay, we are using less energy here. Low, down means low here. Down does not mean south. Okay, rather down means low. I hope it is clear. Okay, so spin down. Okay, so same way, up does not mean north pole. Okay, up means high energy state. Spin up. Okay, so look at here. Electrons have a magnetic field. They are like tiny bar magnets. When we place them in a magnetic field, they will align with the magnetic field just like the needle of the compass aligns with the Earth's magnetic field. It is the lowest energy state, spin down. Let's compare it to the classical bit 0. They can also align in opposite position exactly against the magnetic field. Okay, this is the high energy state called as spin up. It is like the classical bit 1. We are comparing it to the classical bit 1. Clear till now? Okay, so just like in the normal computer, 0001 is a particular command. Okay, so if you have to give a command to a quantum computer, you have to give like down, 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 up. Okay, so this is how you have to give the command. A normal computer will, like you understand Hindi, I understand Telugu. Normal computer will understand the language of zeros and ones. Our body understands ATGC language. Computer understands up down language, spin up, spin down language. Is it clear? It will take and send commands in that language only. That is how the coding happens. The with this I explained you the first difference between a normal computer and a quantum computer. Is it clear? Okay, and one more point I'll tell you. Your normal PC versus supercomputer. What is the difference? Your PC is like 1 candle. Supercomputer is like 1 lakh candles. Means they work on the same principle. Okay, PC and quantum computer, what is the difference? If your PC is like 1 candle, quantum computer is like 1 tube light. Means principle में ही difference है. Is it clear? Supercomputer does not work in any new principle, isn't it? In supercomputer, there is no principle. There is no new principle at all. It will work based on the same principle. घर में आपका जो laptop है, that one and Pratyush are based on the same principle. Okay, but quantum computer is not like that. They both work on totally different principles. Okay, then so what is that principal difference? Okay, one principal difference is okay, like your PC supercomputer. This also uses zeros and ones. This also uses zeros and ones. Whereas this uses zeros and ones. This uses down, 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 up. Is it clear? So that is how the principle itself is different. I hope the first point is clear. Moving on to the next point. Okay. See, a normal computer, okay, can exist in only two positions, isn't it? Only two alternatives. That is either 0 or 1. That's it. Nothing in between. Okay, just like either heads or tails. Nothing in between, isn't it? If you toss a coin, you will either get heads nor get tails. Nothing in between. Okay, so same way for a normal computer, it is either nothing in between. But okay, quantum computers can exist in quantum superposition. To understand the quantum superposition, okay, please imagine this little visualization. Imagine as if you are spinning a coin. Is it clear? Toss karne ke liye, not like this. Spin a coin. Done. And okay, as long as the coin is spinning, means before it lands either as heads or tails, okay, it always has okay certain probability of being heads and certain probability of being tails. At any given point of time, you stop it. Okay, you're spinning a coin, then you have to spin a coin, and then what you will do, you have to stop it. At any point, if you stop it, okay, it can become either heads or tails. We don't know. So it is always the moment when you are going to stop the spinning coin, you have a certain probability of being heads or certain probability of being tails. So it means a spinning coin is in a superposition between heads and tails. Is it clear? It means not only heads and tails are not the only two possibilities. There are multiple possibilities. For example, the moment the coin started spinning, if you stop it, maybe probability of tails is more. If you stop it after 3 seconds, maybe probability of tails is more. Did you understand? So numerous possibilities in between, isn't it? Okay, means at any given point of time, it can be heads and tails like 10-90 or 20-80, okay, or 30-70 or 40-60 or 50-50, okay, or 60-40, okay, 70-30, like that. Okay, at any given point of time, it has a certain probability. Maybe in some positions, it has higher probability of being heads. In some positions, it has higher probability of being tails. But it is neither heads nor tails, somewhere in between. And in this in between also, like this, several combinations are possible. All these are called as quantum superpositions. Is it clear? Oh, then you may ask me one question. Okay, I understood this in the coin example. Okay, but how do you explain it in the quantum particle example? Okay, so in a quantum computer, spin up is like heads, let us assume. Okay, spin down is like tails, let us assume. So is it clear? Okay, in the quantum computer, spin up ko, okay, just imagine that it is heads, and spin down, imagine that it is tails. Okay, then let us suppose spin up is here, spin down is here. Okay, then I told you now, when it is actually north south dikhana hai, so you have to drag it so that during the dragging it is in the superposition. Is it clear? While you are dragging it, it is in the superposition. Okay, let me read it out. The quantum objects can be in both states at once, called quantum superposition. Just like a spinning coin can exist in both heads and tails, that is called as a superposition. Is it clear? It is giving up the precise 0 and 1, allowing some uncertainty. Is it clear? This allows some uncertainty, and it is nothing but giving up, okay, being at two extremes, 0 and 1. A classical bit is 1 or 0 like heads or tails, but qubits exist in a fluid, non-binary. Fluid means what? Uncertain. Non-binary means it is not just heads or tails. It is like this. This is non-binary. Do you agree? Fluid, non-binary identity. Is it clear? A classical bit is like 1 or 0 like heads or tails, but qubits exist in a fluid, non-binary identity. They can exist in a superposition with some probability of being heads or tails. So here heads means up and tails means down. Okay. So a quantum particle can always remain in an uncertainty between spin up and spin down. Agreed? So this allows some uncertainty. So this can be called as quantum uncertainty. Clear till this point? Then you may get one doubt. Okay. The last point only Raja have been explaining since last 10 minutes. So explaining the last point is not so easy. You have to little visualize it. Is it clear? I'll show you. I'll try to explain. Okay. North pole, south pole. This is like, okay, spin up. Okay. North pole, south pole. This is like spin down. Is it clear? Who is that? Last point, Raj. Listen carefully. And I'm comparing spin up, okay, with the heads. Heads in what? In a spinning coin. And if I repeat 10 times also, you will not understand. You will understand if you imagine a spinning coin. Is it clear? A coin ko leke aisa spin kare to, like this. Okay, if you spin a coin like this, I hope you got it. Okay, so heads in a spinning coin. Spin down is compared to tails in a spinning coin. Okay, and then now the next point is, okay, only heads and tails is like a binary concept. But observe this. Okay, this is a fluid. Okay, only heads or tails is binary concept. Okay, but this is heads and tails. Heads compared to what? Okay, spin up. Tails compared to what? Spin down. Okay, so like if you have only two possibilities, okay, like heads and tails, that is binary. Okay, only up and only down, then it is binary. But okay, for a spinning coin, okay, or in this diagram, there is something like this from here to here also. There is some that is like a spinning coin. This is called as quantum uncertainty. Okay, so this one means any position between the north or south. Okay, it exactly aligns spin up. It is exactly opposite spin down. इन दोनों के बीच में जो positions है वो quantum uncertainty. Is it clear? Why uncertainty? Because if you, for example, at this moment, if you leave it, okay, then it will align with the pole, okay, with the magnetic field. If you continue to drag it, it will settle at the opposite thing. Is it clear? Spin, spin up. Is it clear? Raj, don't confuse. No northwest. Why northwest? Yeah. Okay. Yes, correct. Very good. Good example. Okay. So what is the quantum uncertainty here? Like east, okay, northeast, southeast, okay, west, okay, northwest, southwest, all these positions, okay, all these positions are the examples of quantum uncertainty. Very good example. Thank you so much. For example, is it clear for all of you? Probably this discussion made it a little more clear about the quantum uncertainty concept. Okay, so if it particularly aligns with the magnetic field, then it is spin up. Exactly opposite against the magnetic field in which it is present, then it is spin down. In between positions is the quantum uncertainty. So it means at any given point of time, it has a probability of spin up or spin down. If you leave it, it will spin down. If you continue to drag it, it will spin up. Is it clear? Okay. So that is called quantum uncertainty. Uncertainty is clear. Okay. Can I conclude that? Now the applications of quantum uncertainty. What is the advantage of quantum uncertainty? Okay. Simple. Let us suppose. Okay. Let us suppose you are playing a coin game with a normal computer. Okay. Not quantum computer. Okay, you are playing a coin game with a, like in this will be there, no? What do they say? Some games will be there. The word is not striking to me. Okay, some coin game. Is it clear? Imagine you are playing a coin game with the computer. The game is, okay, you have to spin the coin. Okay, spin the coin is like Ludo. You will not, yeah, casino. Yes. Okay. So like say for example, like in like spinning the coin means not exactly you are spinning like Ludo. If you click on a button, the dice will roll, isn't it? So same way like Ludo, it is not a dice game. It is a spin game. The game is first you will spin it. Okay, the computer should guess whether it is heads or tails. Next, the computer will spin. You have to guess whether it is heads or tails. Is it clear? Just like you are playing Ludo with computer. You don't have any friends, so you are playing Ludo with computer. Same way you are playing this coin game with the computer. If you spin the coin first, how do you spin? You're not manually spinning it because it's a computer game. So if you click on that, this coin will spin. The computer should guess whether it is heads or tails. Next, the computer will put the coin. Then you have to guess whether it is heads or tails. Is it clear? And when you are playing this game with a normal computer, listen carefully. When you are playing this game with a normal computer, okay, you have, okay, so that is starting language. Sorry, you have 50% chance of winning. Is it clear? In each game, you have 50% chance of winning. The computer is also having, you and also the computer are having only 50% chance of, because there are only two possibilities. When the computer spins the coin, two possibilities. It should be heads or tails. Any answer you guess, okay, you have 50% chance of winning. Any answer the computer guesses, it has 50% chance of winning. Clear till this point? It means when you try to guess what the computer is going to do, okay, if you guess what the computer is going to do, you have 50% success rate. But same coin game with a quantum computer. And okay, don't worry, अरे coin game खेलने के लिए invent करे थे क्या quantum computer को thousands of crores of rupees spent after all to play the coin game. No, there are other usages. I'll tell you. Wait. Okay, so first understand this example. Okay, so if you are playing the coin game with a quantum computer, okay, then any guess you make, okay, you are bound to be wrong. Do you agree? Okay, because you are bound to be wrong. Such बोलने का possibility ही नहीं है. Whatever you guess heads, it can be wrong. You get tails, it can be wrong. If you say 90% heads, 10% tails, that can be wrong. Is it clear? Why are you bound to be wrong? Okay, because the quantum computer is in superposition. Is it clear? It's not a binary concept. It is a fluid, non-binary thing. Like this, see, for example, here I have taken only, not to waste much of your time, I've taken 10 to 90, but not like that. 199 be a possibility. Do you agree? Okay, 0.0019999 is also a possibility. You have numerous possibilities, countless possibilities you have. So anything you guess, you are bound to become wrong. Did you understand? Okay. So, okay, 199, 298, 397, even more than that. Okay, 0.001, okay, 99.999. Like that, you have almost infinite combinations possible, isn't it? Difficulties. So any answer you predict, you're bound to become wrong. So हम quantum computers को coin game खेलने के लिए invent कर रहे हैं? No. Then what is the use of this quantum uncertainty? Okay, it can be used to create the private keys, security codes. Okay, hacking it is impossible. As if you know it correctly, then you can open it. Okay, if they are guessing it, whatever they guess, they are bound to become wrong. If a quantum computer generates a private key or a security code, whatever the hackers guess, they are bound to be wrong. If they know the key, if you know the key, you can use it. If you are guessing, okay, it means if you are playing with the computer, it will play with you. Okay. So for encrypting the messages sent from one location to another, hackers cannot copy the key perfectly due to the quantum uncertainty. So this is the application of quantum uncertainty. Is it clear? more security possible. If you want to store some data, for example, in biotechnology, DNA profiling, for example, the DNA profiling bill is passed. Okay, and let us suppose if some enemy country hacks our database, then all Indians' DNA profiles will be leaked. They can plan biobar also, dangerous. So database ko hum ek security. Did you understand? National security issues are possible. Joyce, I did not understand what speed matters, how speed matters, hypersonic, supersonic. I didn't understand what point you're trying to explain. But if at all there is something, we'll discuss at the end of the class. So is application of the quantum uncertainty clear? So if you know the key, you can open it. If you do not know the key, you are guessing. It means you're playing with the computer. Then the computer will play back with you. Okay. So same way, okay, we can use this quantum uncertainty in healthcare and medicine. The design and analysis of molecules for drug development is challenging because exactly describing and calculating all quantum properties of all atoms molecules is computationally difficult. See, the point is, like I told you, supercomputers can be used in the drug designing. There I explained the little concept. Just like a supercomputer, quantum computers are also good in drug designing, okay, because they can check all combinations of the, just like this quantum superpositions, they can check all configurational arrangements of the molecules to form a drug. Is it clear? Configuration means spatial arrangement of molecules in a compound, okay? Spatial arrangement of molecules in a compound. So in which arrangement it can work like a drug. In the other arrangement, same components. In one particular arrangement, it can be a drug. In the other arrangement, it can be a poison. So in which configuration it works like a drug. Quantum computers can better predict them. Is it clear? If you still did not understand, no problem. You are not a teacher. You don't have to explain it to the examiner. Even if you are a teacher, examiner is not your student. So you will not have to explain that. Just remember that quantum computers can help in drug designing. Okay, then fine. So I hope you understood first difference between normal computer and quantum computer. Normal computer uses classical bits. Quantum computer uses qubits. So what can be qubits? Okay, quantum particles can act as qubits, like electron, proton, etc. can act as a qubit. Okay, and second difference between a normal computer and a quantum computer is normal computer operates in binary format. Okay, but quantum computer operates in non-binary, fluid non-binary format. So therefore it permits uncertainty. The uncertainty can be used to form the private key security codes and also in the drug designing, etc. Okay, so that is one advantage of the quantum computer. Second one is teleportation. Teleportation. Okay, teleportation means what? Like sending the information from one place to another place. Like in science fiction movies, they show that teleportation of the human beings is also possible. So you will just disappear from here and you will be present. Teleportation. Clear? Understood what is teleportation? Okay, but teleportation of human beings may be a science fiction. That's what I'm saying, Anuj. That is a fiction. But teleportation of information is possible. Okay, it means I'm speaking about quantum internet. Quantum internet. Is it clear? Then so now let us suppose in Ethernet, okay, the wires or the cables are the medium for transfer of data. Do you agree? Data transfer करने के लिए, okay. Anuj, if I say it is possible, like will your purpose be solved? We have to first understand what is that. Then only we have to think whether it is possible or not. If I give you an answer, it may be possible. What did you understand from this? Actually, answer is that only, may be possible. Okay, but I don't know really how did it help you. Okay, so in the first understand the concept, please. Okay, in Ethernet we use wires or cables as a medium for transfer of data. In Wi-Fi we use radio waves as medium, isn't it? To transfer data. Means if I want to send an email or if I want to send some data from, say for example, Bluetooth use करके if you are sending a file from one mobile phone to another mobile phone, so how that particular file is going? It is going through the radio waves, isn't it? In Wi-Fi, okay, the light waves as medium, isn't it? Light waves as medium. Okay, in Wi-Fi, that is just an imaginary name that I have given. We don't have anything like Wi-Fi as of now. Okay, so this is not a correct usage. Okay, I mean to say, if it is quantum internet, okay, then what is the medium? Quantum entanglement as medium to transfer data. Data transfer करने के लिए केबल्स को नहीं, रेडियो वेव्स को नहीं, लाइट वेव्स को भी नहीं. ओके, क्वांटम एंटेंगलमेंट को यूज करें तो वो वाईफाई है. ओके, जो वर्ड अभी तक नहीं है क्वांटम इंटरनेट. ओके, एंड क्वांटम इंटरनेट को यूज करके इफ यू सेंड सम डाटा फ्रॉम वन प्लेस टू अदर प्लेस, दैट इज कॉल्ड क्वांटम द टेलीपोर्टेशन. ओके, सो व्हाट डू यू मीन बाय टेलीपोर्टेशन? Okay, sending data. Fiction is human beings. That is only fiction. Okay, at least I don't feel that it is possible. Okay, then sending data from one place to other place using quantum entanglement as a medium. इसको हम एक मीडियम के जैसा, नहीं तो एक चैनल के जैसा यूज करके डाटा को ट्रांसफर करें तो then it is called quantum internet. Is it clear? Then you will get it out. What is this quantum entanglement? That I teach you. Understood my pattern. So first, the medium is quantum entanglement. So obviously, the next question is, what is quantum entanglement? Then we proceed into that. If this is clear, we'll proceed into what is the nature of this quantum entanglement. First thing, let me disappoint you. Okay, that is, we do not know what is this quantum entanglement, but we know that it exists. इसका nature क्या है वो पता नहीं चला. Okay, but we know that it exists. Is it clear? Albert Einstein said that just like we know that dark matter exists, okay, we know that dark energy exists, but we don't know what is dark energy made up of. Okay, we have seen about the dark matter. Okay, we understood that dark matter is not antimatter, because अगर dark matter antimatter है तो वो matter को negate करते हैं, but we have matter, so it means it cannot be the antimatter. Okay, so we know that there is something called antimatter. Okay, we know that it is not okay, we know that there is something called dark matter, we know that it is not antimatter, but वो क्या है? Okay, we don't know that, but does not mean that it is not there, it is there. Okay, are we just imagining that it is there? No, evidences are there to prove that it exists. Like I told you, dark energy नहीं है तो universe cannot expand at this particular rate. अगर universe में सिर्फ pulling force है तो okay, the universe should shrink. But actually universe is expanding the distance between, so it means, so like this we have evidence to know that quantum entanglement is there, पर वो quantum entanglement का nature क्या है वो पता नहीं. Then again, who said that there is quantum entanglement? Okay, Albert Einstein again. Okay, so Albert Einstein said that quantum mechanics should allow, okay, two objects affect each other's behavior, okay, instantly across vast distances. Okay, it means, let us suppose if an electron rotates on the earth, it can impact an electron in the Mars. Did you understand it? If an electron rotates on the earth, it can impact an electron in the Mars. That too instantly, not after 1 million years, not after 10 minutes, no, instantly. Quantum mechanisms should allow two objects to affect each other's behavior instantly across vast distances. Vast distances means ये room और बाहर वाला room ऐसा नहीं, across vast distances in the space. And okay, he observed that experimentally, he understood that okay, the particles are influencing like that. Okay, but he did not understand how that influence is possible, so he called it as spooky action at a distance. It means some mysterious action at a distance. Is it clear? So it means, okay, let us suppose like it means, look at here, this is my PC and this is your PC. Let us suppose our PCs, we are very rich and like we both have quantum computers. Let us imagine I have a quantum computer, you have a quantum computer. Okay, so in this I am using electrons as qubits, and in this also you are using electrons as qubits. Is it clear? Okay, and now look at here, the electrons in my computer, the electrons in my computer and the electrons in your computer are connected. Okay, so they are connected, so that if I change something about the qubits in my computer, that will affect the qubits in your computer. Is it clear? So all these quantum particles in the space are interconnected. Interconnected through what? What is the nature of this interconnection? That we still did not understand. Okay, does not mean that it is there. See, for example, gravitational waves, 100 years back he proposed, 2015 we identified. So till 2015, okay, so you cannot say it is just some fiction. That is not, fiction is different. Fiction will not have an experimental evidence. But इसका experimental evidence है, fiction नहीं है, ये तो है, पर वो क्या है वो पता नहीं. Maybe in future we will understand. Maybe 100 years later we understand it. But we have something. Okay, so because my computer and the electrons in your computer are interconnected through this quantum entanglement. ये quantum entanglement को मैं एक medium के जैसा use करके, okay, I can transfer a file from my computer to your computer. Did you understand? I hope you understood what is quantum computer with this. With this example, you can understand it. Ethernet, wires or cables, Wi-Fi, radio waves, Wi-Fi, light waves, quantum internet, quantum entanglement is the channel. Okay, so this is the okay, so the electrons in my quantum computer, the electrons in your quantum computer, they are connected. Okay, so that is called quantum entanglement. We are using that one as a medium or channel to transfer the data from one computer to the other computer. That is quantum internet. Okay, so let me explain that. Teleportation. Teleportation of information without physically transmitting the information. Scientists confirm that information could be passed between photons on computer chips, even when the photons are not physically linked. Okay, they are taking photon as an example. It means they used photon as an qubit. Here I explained with electron as a qubit. Is it clear? But these two electrons, this quantum computer, why am I using this shaded thing? Because they're not physically connected. Some force is connecting them, some physical force is connecting them, okay, are not physically linked. Okay, quantum particles can get entangled across the space and time. Okay, if they are connected in space, they are connected in time also. Space and time are interconnected. I hope you remember this. In such a way that when we change something about one particle, it can impact the other particle. It creates a channel for teleportation. Scientists are trying for quantum internet. So is it a reality as of now? Okay, 6G के बाद 7G quantum internet होगा? पता नहीं. Okay, अभी तक तो realize नहीं हुआ. हो सकता है. Is it clear? They are trying for it. Speed will be more only. Okay, and Einstein calls it as spooky action at distance. They have the potential to process exponentially more classical computers. Such algorithms would be helpful in solving complex mathematical problems or predicting multiple particle interactions in chemical reactions, etc. Applications are similar to supercomputer, but here in supercomputer, what 1 lakh computers can do, here one quantum computer can do it. It's much more effective. Is it clear? It works on a different principle. Comparison with regular computer. Quantum computers are not comparable to the regular computer. They work on different principles. Okay. Quantum computers are not faster or better than supercomputers in all matters. For example, let us suppose, okay, if I want to do a problem like 3 plus 3 is equal to how much? Your PC can do it faster than quantum computer. Is it clear? So to be more efficient in everything it does. No. Okay. So quantum computers need not be faster than supercomputers. Supercomputer को तो छोड़ दो, normal computer, your PC से भी fast होने का जरूरत नहीं है इसमें. But they are particularly efficient in certain complex tasks. It means they are expert in some other tasks. Okay. Like quantum computers do exceptionally well in problems that require calculations or probabilities. Just like supercomputers. 1 million probabilities में एक probability को predict करना है तो quantum computer is more efficient. Is it clear? Regular browsing or simple calculations may even be faster on a regular computer than a quantum computer. Don't try to do 3 plus 3 is equal to how much in a quantum computer. Use it, okay, for more difficult computational things. Okay, like predicting one of the probabilities among some 1 million probabilities. In such certain tasks, it is more effective than supercomputer. Is it clear? So issues and challenges. Not everybody is convinced that quantum computers are worth the effort. It means there are some scientists who believe that it will never realize a possible in a year. Scientists believe, okay. Believe that obstacles that are practically impossible to overcome, putting quantum computing forever out of reach. Some mathematicians feel that quantum computers are all like they can never become a reality. But some companies like IBM, Google claim that we might be close, okay, as they continue to cram more qubits together and build more accurate devices. Quantum research in India is solid on theoretical side. It means we are good in theory, but we are bad in practicals because we don't have the experimental facilities, we don't have infrastructure for it, we don't have manpower trained in quantum computers and all that. So theoretically solid, weaker on the practical aspect. So on the whole, some scientists believe that it is possible, some scientists believe that it is not possible. Okay, fine. That is about possibility. Next one, national mission on quantum computing. Most of the people are believing that it is possible. That is the reason why we decided to spend 8,000 crore rupees for a period of 5 years to develop the quantum computers. India, national mission on quantum computing. Is it clear? With an aim to spearhead scientific breakthrough and boost quantum technology-led economic growth in India, Budget 2021 has announced a national mission on quantum technologies and applications, allocated a budget of 8,000 crores to be spent over a period of 5 years. Okay, so it means if a good number of scientists feel that it is never possible, why do we spend so much money on that? Okay, so there is a theoretical evidence, experimental evidence that it might be possible. Okay, so agar ye possible hai to, okay, to be a founder in this technology, to spearhead this technology, so we are spending money. Is it clear? It is to be implemented by the Department of Science and Technology. The national mission on quantum technologies is implemented by the Department of Science and Technology. Okay. Then this is all something related to the national mission on quantum technologies. Go through that. Okay. Next, India's first quantum computer simulator toolkit launched. Okay. So, okay. Meanwhile, let us solve this question once. Okay. Quite a simple question, not even worth discussing, but it was given in 2022. Which of the following is in the context in which the term qubit is mentioned? Quantum computing. Okay. Next, what is this first quantum computer simulator toolkit? So, as the name itself is suggesting, it is not a quantum computer. It is a simulator. Quantum computer ko imitate karne wala, and moreover, it is not a hardware. It is a software. Is it clear? So quantum computer toolkit is a software. This is a software that runs on the quantum computers or normal computers. Guess, is it a software that runs on normal computers or quantum computers? प्रदीप, ये सॉफ्टवेयर को रन करने के लिए क्वांटम कंप्यूटर को यूज कर सके तो सिम्युलेटर टूलकिट क्यों बेटा? क्वांटम कंप्यूटर सच में क्वांटम कंप्यूटर को ही यूज कर लेते? Did you understand? It means as of now, the quantum computer did not realize. It means we do not have quantum computer. We did not make a quantum computer yet. Okay, abhi manufacture karna hai aage jaake. So like till now we do not have it. Now also they are not making a quantum computer. They are making a software that simulates the quantum computer, and the software runs on a normal computer. So that is the quantum computer simulator toolkit. Is it clear? So let us see what it is. In August 2021, the Ministry of Electronics and Information Technology launched country's first quantum computer simulator toolkit. Okay. Something like that, yes. Okay. Quantum simulators are software programs that run on classical computers. Is it clear? It's a software program that run on classical computers. Okay. QSIM. QSIM is not like your SIM card. QSIM is the shortcut of quantum computer simulator. Okay. QSIM is it's not like a SIM card. It is the short version, abbreviation of quantum computer simulator. QSIM is the first of its kind toolkit to be indigenously developed, and it is intended to be vital tool in learning and understanding practical aspects of programming in the quantum computers. Is it clear? Using this, people can learn how to do programming in the quantum computers. ये सॉफ्टवेयर को यूज करके नॉर्मल कंप्यूटर्स में क्वांटम कंप्यूटर प्रोग्रामिंग को सीख सकते हैं. इज इट क्लियर? It is a collaborative initiative brought together by IISc Bangalore, IIT Roorkee, CDAC to address the common challenge of advancing the quantum computing research frontiers in India. QSIM equips researchers to explore quantum algorithms under the idealized conditions. Okay, then making necessary arrangements for experiments to run on actual quantum hardware. Okay, later they try to run such program in the actual quantum hardware. पहले normal hardware में run करके, okay, we learn something about it. Later we may run such software in the actual quantum hardware. Quantum hardware means real physical structure. Quantum computer में use करने के लिए कोशिश कर सकते हैं future में. So this is QSIM or quantum computer simulator toolkit. Is it clear? The evolution of these technologies we have already seen. Cloud computing, we have seen IoT, edge computing, big data, we discussed. Then after that, the Digital India program. Okay, Digital India program. In this, okay, like launched in 1st July 2015. Can we proceed? Totally next topic, quantum technology is completed. Digital India program launched in July 2015. What is the target? Target is to transform India into a digitally empowered society. India को एक digitally empowered society बनाना is a target. Is it clear? Then it is an umbrella program that covers multiple ministries and departments coordinated by the Department of Electronics and Information Technology. Multiple departments are involved, but who is coordinating all those departments? Department of Electronics and Information Technology. Is it clear? So the three main targets are, okay, e-governance and government services on demand. Governments like providing the government services through internet. Is it clear? E-governance. Digital empowerment of citizens. Citizens who are capable of using the digitization or internet and all. Digital infrastructure as a core utility for citizens. All citizens will have access to the digital infrastructure, like digital infrastructure in cell phones, computers, etc. Is it clear? Smartphone, computers, etc. So these are the targets of the Digital India program. Can we proceed? Next, 9 pillars of Digital India. Okay, so 9 pillars of Digital India I have given in the form of an image here. You can go through, and here I have given the 9 pillars in the writing also. One after the other. Broadband highway, connecting villages to the national optical fiber network. Is it clear? Connecting the villages to the national optical fiber network. Universal access to mobile connectivity. It means, like, say, for example, during the lockdown, like the students in the cities, okay, they have taken the online classes. But what about the students in the remote villages, tribal areas and all? They did not have this infrastructure. So universal access to mobile connectivity. It means in the remotest places also, mobile signals should come. Everybody should have a smartphone. Plus every smartphone should have a signal. Internet access, that is universal access. Then public internet access program. Okay, then e-governance, that is governance through internet. Okay, then e-Kranti, it is a national e-governance plan to accelerate e-governance across India. Then information for all, everybody should have access to the information. Okay, and electronics manufacturing, that is a target of net zero imports. It means we can import the electronic devices, but we should also export them. And target is net zero import from the other countries. Is it clear? More indigenization of the manufacture of electronics. IT for jobs, more IT courses for more jobs. Then early harvest programs. Early harvest programs means some project for which you do not start from the scratch. It means abhi jaake land ढूंढ के, जगह ढूंढ के, इसमें factory construct करके, इसमें like equipment खरीद के, okay, and then start the production. No, early harvest programs means using the already existing infrastructure to produce something new. That is called early harvest programs. Projects that can be implemented in a short period of time, including Wi-Fi for all universities, public Wi-Fi hotspots, biometric attendance system for the central government. Okay, so is this clear? These are the 9 pillars of Digital India program. Can we proceed? Then some notable initiatives under the Digital India program. Some important initiatives taken under this program. First one, DigiLocker system. DigiLocker system. Okay, minimizes the use of physical documents. For example, you went to USA for to pursue some degree course or for a job. So after going there, you had to submit some marks memo or some certificate. You have to submit, and unfortunately, you forgot that in the home in India. Okay, so then it is difficult. So therefore, okay, we can keep all our documents in the form of e-documents. They scan and store it in the form of e-documents. Okay, across agencies. Is it clear? The sharing of e-documents will be done through registered repositories, thereby ensuring the authenticity of the documents online. Okay, it means it is not blockchain technology. There will be a repository who controls all these things. There is a repository who controls all these things. So therefore, it will be okay authentic. Is it clear? So there was a question in 2016 based on this regarding DigiLocker. Sometimes seen in the news, which of the following statements are correct? It is a digital locker system under the Digital India program. Yes. Okay. So now, see this answer, because I have given the information, you can answer it. But here, you just have to observe a small thing. You have a small task or a homework. That is, okay, you have to explore a Digital India program and you should know what all initiative comes under the Digital India program. Is it clear? Slightly difficult task. Okay, but based on this question, that is the pattern in this, isn't it? Okay, how to know whether DigiLocker means what? You can, second point you can guess. Okay, it allows you to access your e-documents irrespective of your physical location. Probably second one you can guess. Is it like a cloud storage? Yes. But first one you cannot guess. You have to know whether it comes under the Digital India program or not. So you have to explore Digital India program once, and you have to check what all initiatives comes under that. So do that task. Okay, I have kept as much as possible, but obviously I cannot claim that I covered all the initiatives under the program because the program is so vast. Is it clear? Okay. So actually it is both 1 and 2. Yes, it comes under the Digital India program, and second one, it can be accessed from any location because it is a digital locker. It's not a physical locker. Is it clear? Next one. Okay, consider the following. Okay, so for that, let us first see some information. Open source software means what? Open source software means, okay, the software in which you can do some editing. It is open for you to do some editing. Is it clear? आपके लिए वो open है. आप चाहे तो इसमें modifications कर सकते हैं. You can upload something into that. You can take something from that. Okay. For example, DigiLocker. Okay. How is it open? Okay. How do you say it is open? Because you can upload your documents into that. You can download your documents into that. It is open for your use. Is it clear? Okay, same way Diksha app. Is it clear? Same way Arogya Setu. Okay, in Arogya Setu, like these days it is not much being used, but during the pandemic first wave, second wave, they used it. Okay, in that you have to enter the data. That is like, did you already get COVID, or how many times you got it? Are you having any symptoms? Did you take the vaccination? Okay, all those things. So it means you can add data to it. It means you can modify. It means it is open source. Is it clear? Booking the slots for this vaccination. Covin app. Okay, COVID-19 vaccination platform. So how can you edit that? You can book something. You can book the slot. You can change the slot. Okay, and you can download the vaccination certificate. Okay, so it means you can modify that. It is open on your end. It is open on your end. They're all built upon open source digital format platforms. Open source digital format means any digital format which is open on the user end. User can make some changes to it, upload something, download something, edit something, and all that. Is it clear for all of you? Okay, so now consider the following based on that explanation. Arogya Setu, Covin, DigiLocker, Diksha. Okay, they're all open source digital platforms. Is it clear? Next. Okay, that's all for today's class. Actually, we mostly completed it. It will take me only some around half an hour to complete the ICT. So tomorrow's program is some around half an hour for ICT, and then also I will start defense technology. Okay, so probably tomorrow, day after tomorrow, we will be completing science and technology course. If I don't lose my throat meanwhile, okay, by tomorrow, day after tomorrow, if I do not lose my throat, then we'll be completing it by day after tomorrow. That's all for today's class. If you have any doubts, you can ask. Thank you so much. Thank you so much. Thank you. So seems like no more doubts. That's all for today's class. Good night. Bye-bye.